Good day. So we are now into our discussion of mathematical sentences. Our session objectives are as follows. Define and explain a mathematical sentence, enumerate the type of mathematical sentences, and discuss the different types of compound sentences. So our main question is, what is a mathematical sentence? Okay, so what is a mathematical sentence? A mathematical sentence is one in which a fact or complete idea is expressed. Now, similar to its definition in the English subject, mathematical sentences can be defined as group of words that expresses a complete thought or a complete idea. Another is, because a mathematical sentence states a fact, many of them can be judged true or false. It is also called statement, which is a declarative sentence that is either true or false. So, here is the formal definition of a mathematical sentence. A mathematical sentence, also called mathematical statement, or proposal is a sentence that can be identified as either true or false. Now, are questions and phrases considered mathematical sentences? The answer is no. Questions and phrases are not mathematical sentences since they cannot be judged as true or false. So merely you are being asked with a question in which you're going to reply with an answer. Now, let's look at some illustrative examples. First is 6 is a prime number. So this is a mathematical sentence or mathematical statement because it expresses a complete idea. It can also be judged as either true or false, or we can say whether or not 6 is a prime number. The next example is 6 plus 8 equals 2 times 7. This is also a mathematical sentence because it expresses a complete thought. It is an equation and it can be judged as either true or false. Next is 9 plus 1 equals 0 plus 11. So this is also an example of a mathematical sentence or mathematical statement because it expresses a complete idea and it can be judged as either true or false. So we can say that 9 plus 1 is 10 and 0 plus 11 is 11. So, is the statement correct or the mathematical equation correct? So, we can judge it as false because 9 plus 1 is 10, but 0 plus 11 is 11. Next is, if an integer n is odd, then 2n is an even number. This is also considered a mathematical sentence or mathematical statement since it expresses a complete idea and it can either be judged as true or false. Next is, a stop sign is not in the shape of an octagon. This is considered a mathematical sentence because again, it expresses a complete idea and it can either be judged as true or false. So we can say that not all stop signs is in the shape of an octagon. There are stop signs in which they are designed to be in circular form, in square form, or rectangular form. Next, some parallelograms. So this is not an example of a mathematical statement or a mathematical sentence because it is rather a phrase. It does not express a complete idea. So, some parallelograms, what will happen next? It has a hanging statement. So next is, are quadrilaterals squares? So this is not considered a mathematical statement because it is a question. What are the different types of mathematical sentences? We have the first one, open sentence. What is an open sentence? So an open sentence is a sentence which consists of a variable. Examples: x plus 2 equals 8, and it is my favorite color. So in the first example, x plus 2 equals 8, we can say that the variable there is x. In the next example, it is my favorite color, we can say that our variable there is color. Number 2, closed sentence. So what is a closed sentence? A closed sentence is a mathematical sentence which can be judged to be true or false. It has no variables. Examples: Garfield is a cartoon character and a pentagon has exactly 4 sides. Similar to the previous examples, we can just judge the sentences given as either true or false. Next, what is a compound sentence? A compound sentence is formed when two or more thoughts are connected in one sentence. Words such as and, or, if then, and if and only if allow for the formation of compound sentences or statements. Notice that more than one truth value is involved in working with a compound sentence. So we can simply say that compound sentences are formed by joining two or more sentences joined together by words such as and, or, if then, or if and only if. Now let's look at some illustrative examples. Try to form a compound sentence with the following. So we have the first, today is a vacation, I sleep late. So we can form a compound sentence as, today is a vacation and I sleep late. Alright, number 2. You can call me at 10, you can call me at 2. So the compound sentence would be, you can call me at 10 or you can call me at 2. Next, you're going to the beach, you should take your sunscreen. So the compound sentence is, if you're going to the beach, then you should take your sunscreen. Next, a triangle is isosceles. It has two congruent sides. So the compound sentence would be, a triangle is isosceles if and only if it has two congruent sides. Now, what is a negation? The negation of a statement is the denial of the statement. It is represented by the symbol tilde. The negation is frequently formed by inserting the word not. So therefore, we can say that the negation is actually the opposite in idea of a given sentence. So let's have some examples. Let's have P, or our hypothesis, as today is Thursday. So what is negate P or not P? So the negation of the statement today is Thursday would be, today is not Thursday. So let's have more examples. The first one is, the medicine is effective. The negation is, the medicine is not effective. Number 2, the medicine is not effective. The negation is, the medicine is effective. Number 3, some medicines are effective. The negation is, not all medicines are effective, or it is not the case that at least one effective medicine exists. Number 4, all medicines are effective. The negation is, It is not the case that all medicines are effective, or there exists a medicine that is not effective, or some medicines are not effective. Next is a conjunction. What is a conjunction? A conjunction consists of two or more statements connected by the word and. So in symbol, we have P and Q. Now let's look at an example. If our hypothesis is logic is easy and our conclusion is algebra is difficult. So we have the first one, P and Q. Logic is easy and algebra is difficult. Number two, P and negate Q. So we say logic is easy and algebra is not difficult. Next, number three, negate P and Q. Logic is not easy and algebra is difficult. Number four, negate P and negate Q. So we say logic is not easy and algebra is not difficult. So the next is a disjunction. What is a disjunction? A disjunction consists of two or more statements connected by the word or. In symbols, we can say P or Q. Now, let's look at an example. If P, Carlo is honest, and if Q, Gabriel is honest. So, number one, P or Q. So, we say, Carlo is honest or Gabriel is honest. Number two, P or negate Q. Carlo is honest or Gabriel is not honest. Number three, negate P or Q. Carlo is not honest or Gabriel is honest. And next, number four, negate P or negate Q. So we say Carlo is not honest or Gabriel is not honest. So the next one is conditionals. What are conditionals? A statement of the form if P then Q is called a conditional or implication. In symbols, we have P implies Q or if P then Q. So let us again have some examples. If P, I exercise regularly. If Q, I am healthy. Number one, P implies Q. So we say, if I exercise regularly, then I am healthy. Next, number two, P implies negate Q. If I exercise regularly, then I am not healthy. Next, number three, negate P implies Q. If I do not exercise regularly, then I am healthy. Number four, negate P implies negate Q. If I do not exercise regularly, then I am not healthy. So, those were the different types of compound sentences in relation to mathematical sentences or mathematical statements. So, these are the logical connectives. We have the negation. Our symbol is this symbol, tilde. It is read as not. For our conjunction, our symbol is this one, and then it is read as and. Disjunction, our symbol is this one, and it is read as or. And for our conditionals or conditional implication, our symbol is this, and it is read as if, then.